Buenos días a todos. Ya estamos aquí a punto de comenzar este webinar que se trata de las cosas que tenemos que tener en cuenta cuando queremos hacer lubricación en ventiladores industriales. Good morning, everyone. We are just about to start this lubrication for industrial fans webinar. I would like to say now that this webinar will be all the time in English. However, I noticed that we have some Latin attendees here, but you can stay if you want. You are pretty welcome. At the end of the webinar, we will have some questions, some time to clarify doubts to you. So you can put your questions on the chat, English or Spanish, it doesn't matter. We will just translate it and share it with everyone by audio, so everybody knows what I am speaking. So right now it's 8 a.m. and we're supposed to start just to compliment you guys that has this punctual timing. So let's give them 60 seconds more to the people that is in the lobby to enter this webinar, and then we start. You can use the chat just to let me know how is my audio, if you can hear properly, and also if you can see it.
Yes,
just
perfect.
to check. Excellent. Okay, let's start. Good morning, everyone. Here we are today to share this knowledge with you, all of you. SKF is pleased to share this knowledge with everybody, and we are happy that you have taken part of your time to join us and share your knowledge too, and also learn about what are the latest information that we have available that might help you to develop a best performance within your plant. It doesn't matter the industrial segment that you belong. In this case, we're going to talk about industrial fans, and I believe you have some of those within your facility. So in behalf of SKF Latin Trade, you are welcome to this lubrication for industrial fans webinar. We would like to make a remark here. Try to not put your camera on or your microphone, just to avoid that the bandwidth decrease, and we can perform this virtual seminar in a proper way and everybody can enjoy it. Here we have, you can see me now on the camera, but also you can have my name and my colleague names as well. He is Jose Baron. It belongs to SKF since 2011. He's part of this team, and he is doing as an application engineer, and he's supporting the Caribbean region from Trinidad, Guyana, Suriname, Barbados, Curacao, Aruba, etc. Myself, I am James Tapias. I am the industrial sales engineer for the Caribbean region as well, plus the region of Panama. I've been in the SKF team since 2007, and we both share some experience in sectors like metalworking, cement, mining, food and beverage, and oil and gas. So let's pause and start warming up about the topic that we are just mentioning, the lubrication for fans. But if we are going to talk about lubrication, we need to understand just a simple definition of what is lubrication and why do we need lubrication when we're talking about rolling elements. You know that those rolling elements need to be adequately lubricated because they need to run properly. The bearings are special engineering pieces, but they can't do anything by themselves. In the bearings life cycle, there are other factors that affect the performance of those bearings, such as proper sealing, proper lubrication, proper installation, etc. In this case, the lubricant will prevent direct metal-to-metal contact within metallic, the rolling and the races, as well as inhibits the wear and protects the bearing surfaces against corrosion. Take a look of how small is the lubricant film in between these two parts. It's about 5 microns. So we really need to lubricate those bearings properly. But now take a look of what is affecting my bearing and why do I need to put lubricant on it. If we're talking about factors, let's start with the load. If we have 2 industrial fans, loads, even if you have the same machine, same bearing sizes, and the same, let's say, motor horsepower, they could lead or they could be working on different type of loads. If they are pushing hot air or they are pushing cool air. So the loads might be different, the performance of the units, the thermal behavior of this equipment will be different as well. Let's talk about the speed. It's not the same to have a motor running 1800 RPMs or having a motor pushing air at 3600 RPM. Got my point? Environment. Environment is critical because industrial fans could be on a facility that is mostly clean, right? Like a food and beverage, right? But it's not the same if we have this fan located in a mine, in a quarry, in a cement plant. The pollution around in the environment will be that hard and aggressive that will affect directly the life of my lubricant. Pro will affect the life expectancy of the bearing. And of course, the temperature. Temperature is one of the most important factors within my lubrication program because it affects directly the performance of my lubricant. Let's call it grease, let's call it oil. All those factors are really important when evaluating the application because they help me to implement a proper lubrication system. But you see in the center a bearing. The bearing is also important. Why is that? The bigger the bearing, the bigger the friction is creating, right? So we need to consider all those things to achieve a proper lubrication system for that particular, let's say, point. In this case, the 2 bearings on a fan. Moving forward, in this case, in this picture, we have a centrifugal fan in an industry. It's a combination of an electrical motor that could be driven also by a turbine, doesn't matter. But then the fan, which is a simple rotor supported by a shaft, and this shaft is supported by two bearings. But this particular fan is operated with certain specific parameters that are managed by the operation, let's say, is crew, operator's crew. But let's take a look about this. If you have a pump or a stone crusher with the same type of bearings that the fan is using, the loads and the performance of those bearings will be totally different because they are behaviors specifically for every one of these type of equipment. At the end, all this will affect how the machine runs. It's just a rotor, it's just a motor, but the loads are totally different. And you need to look, when you analyze a situation on this type of equipment, the complete scenario. If you're going to analyze why a bearing is having special conditions in a fan, don't look only the fan. You need to analyze the motor, the structure, the process parameters, the lubrication, etc., etc. Just checking, audio is okay?
It's okay.
Great. But what is a fan? It's a simple question. But the fan is not more than a machine that provides speed and pressure to a gas. In this case, could be air, hot gas, I don't know. It's a fluid that when it passes through the rotor on the fan, it gained or it obtained speed and pressure. Normally, what is created on the bearings are the reactions by trying to push this air, because a fan needs to work against the atmospheric pressure and also all the resistance that the piping can cause, right? So these loads that are created on the rotor are transferred directly to the bearings, right? But what type of loads are we having on those bearings? We got two types of loads, radial load and axial load. The radial load is generated by the own weight of the assemble, the rotor, the shaft, and some other components that are supported on the two bearings. Mostly, all the time, the axial load is created by the differential pressure that the fan is, well, the performance of the fan, basically. Remember that this axial force, it depends, let me use the pointer, it depends on the inlet area, right? And the differential pressure between the in and out. This relation here will create the axial force that my bearings will be supporting. But what type of fans do we have? Who regulates the construction of those fans? The AMCA is the association that normally controls the design of centrifugal fans. According to the standard 99-2404-03, we have different type of fans configuration or arrangement that at the end, based on the type of industry, you must select one or another. But what is important for us is that based on that arrangement, our bearings, right, will have different type of performance, and we need to take control of this. We need to understand what to expect in order to properly address actions that will help me to extend the lifetime of these bearings. You can see, for example, I'm gonna use the pointer again, this type of arrangement here, where the rotors are overhung, right? But also there is one input and one output. Look here that we have two bearings, right? And each of those bearings will support different type of loads. In the second one, we have the same, one in, one output, right? But in this case, the rotor is not overhung, the rotor is between bearings. In the tier one, we have the rotor, and here you notice we have a double rotor. The rotor is still in between bearings, but here we have two inputs, right, and one output. So you need to understand this, because depends of your fan arrangement, the loads might be different, even if you have the same size of bearings or the same speeds. You need to understand how the bearings are transferred into each bearing. Let's take a look in more detail. In this case, this is an arrangement SW-S1, only entry, only output. Normally, the axial load will be supported by the fixed bearings. The fixed bearing is generally the transmission side, but according to the arrangement or the layout of the rotor, this might change. So this transmission side bearing, you notice the two arrows here, will support a combination of loads, axial load plus radial load. But what type of load is supporting this bearing? Basically, this bearing is supporting the rotor weight. So just thinking about this, you can understand now that this one here will need different type of, let's say, features that when they are both combined, my fan runs properly. Let's go to this picture right now. This one has one input, one output, but now is in between bearings. So the load is divided, let's say this way. We are assuming that in this side of the image is the driven equipment, the driving equipment. And we have axial load and radial load in this bearing, and only radial load in this bearing. For the DWDY arrangement, which is double enter and one output, the axial load is removed. Why is that? It's because as we have a double entry, our axial load is balanced. So basically, my bearings will support, ideally, no axial load, right? But 100% radial load, because the axial loads created here are the same, but in the opposite direction. Moving forward, we would like to know what my bearings do when they are wearing out, but what people do when they are starting sensing those symptoms. So here we have some symptoms on centrifugal fans bearings while they are in operation. We could have that because of the normal operation, temperature increase or the vibration and noise increase as well. Sometimes they just increase, boom, in a big amount. But then, why is the reason this happened? Temperature increase uh, uh, is something that happened because of the friction inside of the housing. But then, what we normally do, not me, but what people do on the facility is that they start using some ways to keep the bearing cool, using air pressure, or sometimes putting some water hose on the housing, right? Water hose on the housing to keep the bearing cool. In the other hand, hold on a second. Okay, got you. Just text me that you are seeing it now. I am using the pointer. Well, I am using a pointer very little, so it doesn't matter really. But I try to explain more myself about what I'm doing here. Talking about the temperature increase and people trying to implement substandard refrigerating system. This is not good at all, because the only thing that you do is to cheat on the RTD that is sensing, if you have one, the temperature of the housing plus the bearing. The only thing you are doing is hiding a problem and not allowing the maintenance crew taking real actions to improve this problem, finding the root cause of what is making the temperature increase and fix it. When the noise or vibration increase, normally this is because in high frequency, let's say in SKF, we call this a variable called G's enveloping is also increasing. But when the G envelopes increase, normally what is done is that the relubrication intervals become shorter. So you are putting more grease on a bearing, but then when you add in more grease, and more grease, you are over lubricating. More grease in the housing means more friction. More friction means more temperature, and we have a combination of factors that will affect the behavior or the performance of these bearings. Sometimes this lubricant ingress affect positively the temperature side, but this will not be like all the time. So what's happened is that you are not really attacking the root cause. You are only learn how to live with a chronic problem. Oh, the bearing is hot, put some air, leave it like that. Oh, the bearing is making noise, put some lubricant, leave it like that. So you learn how to live with a chronic problem, and that's not good, right? Let's take an example of what I'm talking about. I hope you don't have this type of situation on your facility. This fan here is a centrifugal fan driven by an electrical motor. But if you notice here on your right side image, customer is accustomed to run this fan at about 90 Celsius degrees, right? And he's just installing these air lines here and pushing air pressure into the bearing housings just to keep it cool. And that's not good. So it is important to have all the information of your fan, your performance charts, your operating conditions, in order to understand how the fans operate and what to expect when doing changes. Some fans might run normal speed, other fans might run variable speed. But if we don't do that, if we don't know, we don't have that information, we will be blind all the time and trying to identify the root cause of a problem. But then, what should we use for lubricating a fan? Grease or oil? Might the OEM tell you what to do? But if you don't have that, you really need to use lubricant selection flow chart or criteria in order to help you to select what is the best lubricant and lubrication system for your fan. We are not going in detail into explain this. This is part of the rolling bearing catalog of SKF, so you can download it all the time. You can use it if you need assistance, or you can contact us back. But moving forward, let's take a look of why we choose grease of oil when we're trying to select a lubrication system. Grease, the main reasons to choose grease is cost effectiveness and simplicity. Grease is easily retained in the bearing and housing, thus requiring less complicated sealing arrangement compared with those for oil lubrication. The main exception for choosing grease are in applications where operating conditions require a grease relubrication interval that is unacceptable, is too short, or lubricating oil must be used for other purposes, like in gearboxes. Another reason could be like we need some heat removal capability. In this case, oil will be the best choice, right? Or purging or removing used grease becomes kind of expensive to handle. So there are so many factors, but mostly 80% of all bearings are grease lubricated. Why is the oil? What is grease? Just a basic explanation here. Oil is an oil base plus some additives that will attack specific aspect of my situation, like avoiding corrosion or keeping water outside so the oil will behave as it's supposed, and others. In the case of the grease is a base oil with other additives as well, but also a thickener. And this thickener, it's what gives me different type of operating temperature ranges, or will also give me, according to the NLGI classification, different grease consistency or hardness. So basically, this is the two difference between grease and oil. But now, going back to the fans, we already know about greases, we already know about oils. Let's talk about fans, how we analyze our fans. Let's say I have this problem. If I have this type of problems on my facility, I need to do a condition analysis of the bearings while in operation. How to do that? Well, first, you need to analyze your fan like a static machine. You need to do a free body diagram. And you need to understand how the loads are divided between the supports, but also be aware that your fan could run at a variable speed. Variable speed means different differential pressure. Differential pressure means different loads on the bearings. So you need to understand how the load changes with respect to these different possible operating conditions. Here you can see I am using the pointer right now on the left graph. Where is this little fan here, sketch. what we do is that all this analysis is previously done, knowing the rotor weight, the type of bearings, the size of the shaft, the weight of the shaft, the type of motor, the power of the motor, and so many other information that will help us to analyze the condition or how my load distribution is on this fan. In the right side of your image, you will see two graphs, right? The top one is a combination of delta pressure in the horizontal axis plus axial force in the vertical axis. This scale is kilonewtons. In the bottom graph, you must have a combination of how the temperature changes when this pressure changes, also the axial force changes. So as you can see, that we have this point here, 222 delta pressure, and my temperature is around 72 Celsius degrees. But if we somehow modify the operating condition, I can go to 406 delta pressure, and my temperature will jump from 72 to 83. So this is a way that we simulate how my fan will operate, because at the end of the day, you can do this on your facility by changing the RPM of your motor or turbine, or also mechanically open and closing the damper of the fan. Normally, a bearing must operate under 70 Celsius degrees when running. If this bearing is running over 70 Celsius degrees, I advise you that you evaluate what special considerations do you have, and if you need an additional system that helps you to evaluate heat from the housings of the bearing, because maybe it did not select an appropriate lubricant for this application. So could be a lubricant issue, or could be a heat removal consideration. But my advice, always try to run bearings under 70 Celsius degrees. How can you do this? SKF support all these bearings analysis using software called Galaxy, that basically allows us to estimate by simulation the temperature of the bearing when they are running. So now I'm gonna put a video here. Lily, I would like to check with the audio.
Okay.
Just let me
Jose,
just go
please.
play here.
Okay.
Take out the pointer.
Jose, it's okay?
It was okay, the video. Did you guys hear the speech? Lily, Jose?
Hi.
Jose,
Okay.
you have audio.
Okay,
Okay,
perfect.
I have audio now, right now. Okay, good morning, everyone. Uh, this application for for the analysis, the different variables of the bearing is to make to very easy this process, because if you don't have this type of tools, it's necessary to do that analysis manually. The different variable of the machine, in this case a fan, it's necessary to know previously to introduce that information in the tool. So to get the result, analyze what is the different load ratio, temperature relate to the delta pressure. Before, James was explaining about the different relate with the delta pressure to the temperature, and how that affect directly the load ratio actually of the bearing, main with the load locating bearing. For
Okay.
example, in the coupling side, in this case, to know that, it's necessary to do all the process. For do this, you can contact with us to 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 do this type of analysis. But before, it's necessary to know all the variable to introduce them, or to check all the variable in these tools.
Okay, Jose. Thank you for this.
Okay, thank you.
All right, let's continue. Yeah, I was saying about this report, but what can you obtain through this report? There are several things that you can get out and use it as your preference, because even can give you some estimation of the lifetime of your bearings. Through this, we can do a complete analysis of the application in order to obtain a clear conclusion. But what it means to you, a clear conclusion? Based on the lubrication analysis, we will obtain this graph as you can see here. But check yourself, what can you conclude from this graph? What can you conclude from this graph? If you look, and using the pointer again, pointer here. If you look, the blue graph refers to the left picture, which is a bearing housing that is being lubricated with grease using a spherical rolled bearing on a sleeve. In the other hand, we have the green graph, and this one refers to another system using an SONL housing, which is a bearing housing where the bearing is being lubricated through oil splash. Then, if you look, here we have the load in this center graph here in the horizontal axis in kilonewtons and the operating temperature on the vertical axis. If I am using grease to lubricate these systems, you can see that the operating temperature will be always higher than the green graph. Remember, this green graph is using oil splash. What is the main difference? An oil splash system, because uses oil, also helps to evacuate heat from the system. Then this type of exercise, it helps to make you define if with this operating condition, I have to change my current lubricating system. Not always you have to make that change. It is possible that you need to choose a different type of grease, or it's also possible that you could implement an automatic lubrication system before you switch to oil. Or it's possible that if your case is so critical, where you maybe can even use an oil splash system, and you have to look for a continuous relubrication recirculating oil system, where in this case you might need a pump, you might need a filtration unit, you might need a heat exchanger that will be able to constantly supply in oil at a lower temperature, of course, but also extracting here from the system all the time. So this is the difference. Once again, two systems lubricated by grease and one system lubricated by oil. The performance of a bearing when you have lubrication by oil, you can notice that the temperatures are lower than when you have a bearing lubricated by grease. There are several factors why you choose go one to another, but you need to do that. Jose, it's your turn to talk about the automatic lubrication in fans. So I just gonna pass the slide for you. Jose. Lily, can you unlock microphone, Jose's microphone?
Yes, I have.
Jose?
Jose?
Okay, well,
Jose?
okay, I'm here, yeah. Can you hear me completely good? Okay, for the automatic lubrication, it's an option for become the lubrication process, give a step for the reliability or your lubrication. It's this is a main option for because the bearing in the fans need to be in every in some cases need to be lubricated continuously to do something like the to avoid the contact, the metal to metal contact, and reduce the risk of the contamination, and doing a replenishment with the dozen of the lubricant day by day or for a short periods. In this case, this is a real case in a fan when that fan use two bearings 22 to 34 SKF, and the dimensions are showing in this slide. The main dimension are the bore diameter and the external diameter. Before, we need to know what is the conditions. For example, the operating speed and what is the load ratio. In this case, this bearing have a load ratio medium. For that reason, this table is on your general catalog. Before, the general catalog 10,000, and now the general catalog 17,000. There are the number of page, and use this criteria to know when to use or make the decision when you use lubricant, grease, or oil lubricant. In this case, you need to use this factor, call it a speed factor. This is a result using the dm is the bearing mean diameter a bearing mean diameter is the practical
You want me to
equation
use this slide?
using this formula, using the bore diameter plus the external diameter of the bearing multiplied by 0.5. With this result, you can use it multiplied by the operating speed, and the result is a factor that depends of that you know what is the recommended limit for your bearing and take the decision to use grease or oil when this factor is upper to the recommendation, to the general recommendation in the table for spherical roller bearing in this case, you know that you can use grease. Look at the note. Beyond this limit, the standard grease performance is not good. So, using you know, for that bearing, notice the speed in this case is medium. This criteria is using for the selection of the grids suitable this type of bearing with the different variable or open. So LG WA2 is typically used in, but it's not only the main criteria. The criteria are to check the different condition and temperature to use that lubricant for your fans. This is other tool, SKF dial set, using to know what is the quantity and the interval for the re-lubrication. And when the different condition, check that the tools recommend some grease. In this case, select or choose the LGWA with the different condition at the temperature, bearing operating temperature. And the result are here. Using a system 24, can you use for 12 months your lubricant?
Good. So if you need any assistance, Jose, you're still there? Shall I continue, Jose? All right, I guess I will just continue. Well, he was just showing here you that there are some variables that will lead you to decide when to use grease or oil when you're lubricating a bearing. But also if you are in the grease side, there are other tools that will help you to determine how often and the lubrication intervals that you need to implement for those bearings. We are entering now in the last part of this webinar, and I would like to point on the condition monitoring, where finally using different type of techniques, you can control and evaluate the behavior of your assets, fan, motor, pumps, compressor, etc. In this case, fans. But the idea is that you use what changes on the performance on these bearings to evaluate and to make decisions. If you have lubrication problems, normally at the beginning of the presentation, I said that vibration will change noise and also temperature. Using a temperature gun, you can control how fast is the temperature changing on your bearings. But also if you have some type of equipment that allows you to monitor the vibrations, not only for the entire machinery, but let's say for the bearing specifically, you can trend, right? You can trend how is this doing. If it's going slowly, if it's going too fast, what then is the root cause of this problem? So at the end of the day, what I'm trying to say is that you need to implement in your maintenance strategy some type of vibration monitoring, temperature monitoring, ultrasound monitoring systems in order to control the performance of your assets. Fans are very critical components on a facility, and one thing I know for sure is that when they are down, they are not down for just 1 hour. You have to get the whole rotor out, you have to disassemble the casing and all this kind of things, and it's kind of messy. So better you control and take actions in time before you have an unplanned shutdown. And just to finalize, let's read some conclusions about what was presented here. Allow me to read it. The analysis of a failure event in bearings of any rotating equipment must be approached from the perspective of the total asset. As I mentioned, the complete asset. Provision of design of standard centrifugal fans, obey the ANCA standard 99-240403. The loads on the bearings in a centrifugal fan, we know depends on the final fan arrangement. Symptoms such as sudden operating temperature or noise increase and vibration on the bearings can be consequences of the fan operating conditions. Solutions like shorten lubrication intervals or install external cooling system like compressed air or water mitigate the consequence, but are not a definite solution. Last one, running an analysis of the operating conditions in a fan is the best solution with the objective of finding the root cause of the system generated by the operating condition of the fan. This type of analysis allows you to select the adequate lubricant system for the fan bearings based on the operating conditions of the assets. And be aware that all our lubricants, SKF lubricants, bearing seals, any product that you might need to make your facility safe in order to not have surprises with out of stocks, things like that, or surprises having undescribable failures, I advise always just to go to your authorized distribution network. Any country you are, always go to the SKF network, because that is the only way that you can guarantee that your item, whatever you just purchased, is genuine. There are also some tools that can help you to identify if this product is genuine. You can download an app from your Apple or Android, thank you, Android website, which is called SKF Authenticate. And with a simple procedure, taking some pictures of the product, you can send that information to our headquarters, and they will shoot you back with the information about it is genuine or not. So with this said, I conclude this webinar, lubrication for industrial fan bearings. I hope you enjoy it, learn something, but now is my time to hear about what you have to say or what you have to ask. If you have any questions, please, it is your time. So thank you first for paying attention to this webinar. Go ahead.
Thank you so much, Larry. We wait the questions for the participants. And one question is, what is the minimum temperature for oil lubrication?
Jose, would you like to answer that question? What is the minimum temperature when you have a bearing lubricated by oil?
Okay, the minimum temperature is not a criteria for to make a decision to lubricate with oil. The main criteria is the axial load, and how is the combination between the three criteria: temperature, delta pressure, and axial load. But when the fan are operating with a temperature average in between 40 to 60 degrees Celsius, it's probably that can use grease, but depends to remember the speed factor. When the speed factor is upper than the limit, it's necessary to use oil lubricant.
Yeah, I would like
Okay.
just to add to this is that you have different type of oil lubrication. You know, you have oil splash, you have oil bath, you have circulating oil systems. So one of them will operate differently in your bearing. But if you know that your bearing is running hot, you need to consider first, why is it running that hot? Is the proper bearing? Is the proper oil? Is lacking heat removal system? So really and truly, there is no maximum temperature when you're running with oil. You need to consider also the oil performance. Remember, the viscosity of an oil changes half every 15 degrees regarding the selected viscosity. So you need to really take care of this and be careful, because an oil can pass from, let's say, 200 centistock viscosity, and the next 15 degrees is already 100, and it will not operate as it's supposed.
Okay. And the another one is, with which method or instrument do you recommend evaluating the correct lubrication?
Say that again, Lily, sorry.
Again, with which method or instrument do you recommend evaluating the correct lubrication?
Well, I might think this question is quite wide because when you need to select a lubricant or lubrication system, you have to do a complete analysis of your asset. If you're telling me what to use in order to control the performance of the lubrication, well, there are several things that might help you. Vibration is one. In SKF, we use the gist enveloping variable to control friction in the bearings zone, high friction, high frequency. We can use temperature. We can use ultrasound. But I believe if you can take samples of this lubricant and perform some tests, let's say mechanical tests like oil dropping and consistency and all these kind of things, they will give you a better understanding of how it is behaving. It's a combination of things that you can do to control the lubrication parameter. Of course, reliability started from the design, right? Not when the equipment is running and you want to know what lubricant to apply. You need to come with that information in the previous stages. So you analyze the machine. Let's say the OEM give you some recommendation, but that's not for granted because they give you that based on the machine itself, but they don't know where are you going to install it, if it's a cool environment or it's a hot environment in the Caribbean, or if it's for there will be a mine close by that will drop some particles in the air. So it's a particular for you. So better you do your own analysis and make sure that you do it right, because the machine will appreciate that you put the lubricant at the right amount, at the right timing, with the right viscosity and additive, whatever, and you will have that as a result and a reliable machine. Any other question, Lily?
Okay, another one is the vibration crest factor a reliable value for evaluating lubrication?
Well, the crest factor is a variable that vibration analyst uses to measure the amount of impacts that you have. But I believe this crest factor will also give you information more about the performance of the bearing itself, but not the lubricant. And a bearing can be affected by many reasons that the lubricant can cover. Let's say if there is an overload on the bearing, you might have some temperature increase that will affect the performance of the lubricant, right? But the lubricant will not support the deterioration of the bearing itself. And as I mentioned in the slide, when I said when the vibration increase, they try to put more grease. Yes, the vibration will decrease, but the temperature will increase. And it's a combination of things that at the end of the day lead to the deterioration of the lubricant. So a crest factor measures level of impacts, but performance of the lubricant or the lubrication itself in the bearing or in the application, I will suggest to use more ultrasound or GIS enveloping. Yeah.
Yes, to complement that answer, the Crest factor in the waveform is are focused on the difference on the, for example, deterioration of the surface in the bearing or the mechanical component. No, not always are related with the performance of the lubricant. Makes sense with in the gearboxes, for example, the crest factor increase when a teeth of the gear have problem. In the bearing is, for example, when a roller or ball have problem, or the inner ring or the outer ring have problem, the crest factor increase with the behavior of that fail or that failure mode.
Here we have another question. Let me read it just to make it translate. If I have a fan with a very long time running, oil lubricated, can I change the lubricant type to obtain a better performance? Well, if I understand the question, I need to separate two things. You are talking about performance of the oil or performance of the fan. If your answer is performance of the fan, I will say that you need to evaluate what is not allowing you to obtain this performance of the fan. Plus, if you are talking about performance of the lubricant, it might be because you are facing some failures already, that the fuse is the bearing. I might say, I don't know. If you are changing bearings that fast, you need to analyze if it's a assembling problem or is a lubrication problem. Normally, when you have a lubrication problem, you will see that right away. You start the fan and somehow the vibration or the temperature will increase in the housing quickly. That is a symptom that you need to pick up and say, why is this always happening? So you need to do an evaluation and check if your lubricant is good enough, your viscosity. If it's a long fan running, I might consider that there might be some other factors that are affecting this. Perhaps the beginning it was supposed to run 1200 RPM and now it's running 1800 RPM and nobody is noticing because the OEM manual is lost. So changing the lubricant might give you some benefits. So my advice is do an evaluation of the current situation today. Yeah.
Okay, another question is, what is the minimum temperature for oil lubrication and the maximum temperature for the high temperature grease?
What is the minimum temperature for oil lubrication? Well, as cool as can run as the best, I believe. that will be my point.
For complement that is, remember that the geometry of the bearing have a stabilization between 120 degrees Celsius to 150 degrees Celsius. Try to use a oil lubrication lower with the temperature lower than that temperature is the general recommendation. Remember the geometry stabilization of the bearing.
Well, you mentioned something about the bedding. They were asking about maximum temperature for the high temperature grease. I will say we need to double check on the catalog. I don't have it here in my hand. But if you are asking for that, is because you have some application that runs in a pretty high temperature, that you might need a high temperature grease performance. So we can discuss this later. I appreciate you give your contact to Liliana through the chat, so she can share with you our lubricants chart, and we can also help you to select what is the best option for you for that application that you might need this high temperature grease. I do not remember how much it is the maximum value, but yeah, we have a few greases that can withstand temperature higher than normal, like based on polyurea or something like that. Is there any other question, Lily?
For a polyurea, the high temperature is 150 degrees Celsius.
Okay, that's good.
Okay, another one is the size of the bearing varies depending on the performance or load.
The size of the bearings, what?
The size of the bearing varies depending on the performance or load.
I would say that you select your bearing based on the loads that you have on your application. Because yes, the performance of the bearing, if you do a wrong selection and you need a bigger bearing, well, this small one will fail quickly. So if I understand the question, the sizes, the main variables or dimension of a bearings, yes, depends on the loads that they will support while in operation. That's completely true. Here we have another question in Spanish. Let me just read it. Where I work, I have some problems with a fan bearing for a long time ago. This bearing has been changed several times, but it continues performing with vibration, and this increases when we lower the load. The question is, this vibration has to see with the bearing used or the lubrication, excuse me, is the vibration related with the bearing used or the lubrication? Every fan has a performance chart, and OEMs normally give you in that performance chart another chart about how the fans behave in vibration terms, not how much, but how it behaves. It will increase or decrease based on how close are you left or side or right of your best efficient point. If you have somehow changed the load on the fan and the vibration increase, you need to do an analysis vibration related, because you said you decrease the load in megawatts. MW is that megawatts? must be something else affecting this bearing, like could be passing through a resonance area, right? Remember that natural frequencies are related with the structure itself, the rigidity and the mass, but also part of the rigidity is the process, the air, or the, yes. So take a look of that using a vibration analysis, because at this moment I could not say that this is due to lubrication. And also you don't mention here that this is it is a sleeve bearing, so a babbitt, right? Very sensitive. So my advice is you have to do a check on vibration. The lubrication in a babbitt bearing, it's also very critical for the type of problem it causes, like oil wear,
Yeah.
oil whip,
For,
things like that. Another
okay, a
question here.
recommendation for that is
Okay.
to use other type of analysis. Not only vibration is possible to use a modal analysis to know what is the behavior of in the starting the second moment that of that fans and the operating condition relate to the vibration for that babbitt. It's necessary to use a modal analysis.
Here we have a question. Let me just translate it for you. What are the temperature limits for the bearings respect to the, let's say, babbitts for large fans? Tiro forzado, Jose. What are the temperature limits of the bearings respect to the, it uses cojinetes, so I will say is making reference of a babbitt for large fans.
Okay, typically using maximum 60 degrees Celsius to the temperature higher, it's possible that reduce the oil pressure, that the oil pressure in the babbitt is significant because the stabilization of the shaft stability depends on the pressure and temperature. So typically they are using 60 degree to 70 degree, no more.
By experience, I have seen rolling element fans or fans supported in rolling elements with higher temperature than babbitts bearings with higher a large ones. But normally those big housings for babbitts have also cooling systems, water piping inside with some copper that remove heat. So I really don't understand if you must expect higher temperature because it's bigger. You can have bigger fans running at a normal temperature once you have the proper lubricating system on place. And rolling elements fans, once you do not have a proper lubrication program in place, you might have variables behavior. Sometimes it's hot, sometimes it's cold, because normally the load is constant. So not supposed to change that much. And And to finish here today, we have the last question. It says, how often within normal conditions of operation do you advise to make a complete cleaning of the housing and the bedding, and what product do you advise to use? How often within normal operating conditions do you advise to clean the housing and the bedding, and what product you advise to use? Jose?
Excuse me, to clean inside the housing?
Well, I will say that if you are, I don't know, we have to take an example here. Let's talk about a bedding, a fan that is supported by two SNL pillow block, which are lubricated by grease. And you also have in place predictive maintenance program that controls the behavior of your fan. Normally, you don't do this as a preventive task. Like every year, I going to change the grease and clean the bearings because I want it. Remember, you have costs associated that you must want to invest in something else. I will say that if you have a proper lubrication system in place and a proper relubrication program, if you can control the behavior of these bearings and it's in a good condition, what you want to get inside. You're not supposed to do that, because when you do it, you could be the reason of a near failure. If it's running okay, leave it okay. You must do is maybe a cleaning outside or something like that. But if you really want to do it, maybe it's because you don't have this type of program in place. And well, my advice is not to do it if you have control. But if you want to do it, normally, I don't know what to say. It could be every time you do a shutdown, but this will take a while, changing and cleaning all your fans, bearings, because you want it. It's not advisable to do that. So my advice is better implement a condition monitoring program that will give you the information enough to decide when to do a bearings replacement, and in that case, then you do a complete cleaning of your bearings fan. Well, I would like to thank you all for attending this webinar. If you have more questions, my advice, please put it on the chat. We will, in the next time or days, contact you back and discuss with you about your particular situation. We will also somehow share all the questions so you can all have it about this webinar. From my side, I'm very happy that you take your time once again to join us. Remember, in SKF, during those days that I advise you to keep safe and wash your hands, you can attend other webinars that we will be doing online, totally free, regarding other technical topics. So, no saying more. Thank you very much.
Thank you so much, Larry, Jose.
Thank you.
Thank you for all
very much.
participants.
Okay.
And we wait and another webinar in next time. Thank you so much for all.
All right. Bye, Lily.
Bye.
Bye, everyone.